Have you ever just stopped and wondered what's holding everything together? I mean, what's really holding the world together on the smallest possible level? Well, today we're going to pull back the curtain on the invisible forces that build our entire reality. So let's start with a simple grain of salt. Why is it a tiny, hard crystal? Why isn't it, a little puddle or just a puff of gas? And then you've got water. What makes it a flowing liquid completely different from that solid grain of salt? Or how about this? Take a paper clip. How is it that you can bend it and completely reshape it, but if you tried that with a salt crystal, it would just shatter into dust? It turns out the answer to all of those questions is exactly the same thing: chemical bonding. This is the invisible glue that defines the properties of literally everything you can see and touch, and we're about to figure out exactly how it works. So, first things first, why do atoms even connect with each other in the first place? Well, it all boils down to one single universal drive: a quest for stability. See, in the atomic world, being stable just means having a lower energy state. It's less chaotic. And the ultimate goal, the gold medal for any atom, is to get a full outer shell of electrons. That makes them incredibly stable and chill, kind of like the noble gases. And bonding is how they make that happen. You can actually think about it like friendships, right? People form connections with each other to feel more stable and secure. Well, atoms do the exact same thing. They form these bonds to get to a much calmer, lower energy state than they could ever be on their own. Okay, so if the big goal is stability, how do they actually pull it off? Well, it turns out atoms have three main strategies to get that full outer shell. They can give electrons away, they can share them, or they can create this massive chaotic swarm. Let's start with that first one, the give and take relationship. This is called ionic bonding. It's pretty straightforward. One atom literally gives an electron to another one. This creates two charged particles, or ions, one positive and one negative. And you know what they say about opposites? They attract. That powerful attraction is the ionic bond. And this intense magnetic-like pull is what creates super hard but brittle crystals that have incredibly high melting points. Sound familiar? Yep, that's your table salt. But what happens if no one wants to give up their electrons? Well, then we move on to strategy number 2, sharing. This is called a covalent bond. Here, atoms cooperate. They share electrons so they can both pretend they have a full outer shell. It's kind of like two students sharing a single textbook for a class. Neither one actually owns it, but they both get the benefit. And believe me, this sharing strategy is absolutely everywhere. The water we drink, the oxygen we breathe, and yeah, the incredibly complex molecules that make up you and me, all of it is held together by these powerful covalent bonds. All right, time for our final strategy. And this one's a little wild. It's called metallic bonding. Think of this as extreme community sharing. You've got this fixed grid of positive metal ions, but their outer electrons have basically just left home. They form this free-flowing sea or swarm of electrons that belongs to the entire piece of metal, not any single atom. This free-for-all electron swarm is the secret sauce that makes metals so special. It's why electricity can flow through them so easily. The electrons are free to move. And it's why the atoms can slide past each other without shattering the whole structure. That's what makes metal bendable, or malleable. So now we know how atoms connect, but here's the thing. These bonds don't just randomly glue atoms together. No, they build very specific three-dimensional shapes. They literally create the architecture of molecules. And it all comes down to one beautifully simple rule. It's called VSEPR theory. And all it really says is this: electron pairs hate each other. They're all negatively charged, so they repel each other. They are constantly trying to push each other away to get as much personal space as they possibly can. Oh, and here's a great way to picture this. Imagine you tie a few balloons together by their knots. What happens? They instantly arrange themselves into a predictable shape, right? Pushing away from each other to get their own space. That is exactly what electron pairs are doing. And this constant pushing leads to very predictable shapes. If you have two groups of electrons pushing apart, you get a straight, linear molecule. If you have 3, they form a flat triangle shape. And with 4, you get a 3D pyramid we call a tetrahedron. The shape is a direct result of that repulsion. It's that simple. Okay, hang in there. We have one last crucial concept to cover. So far, we've been talking about the super strong forces inside of molecules. But what about the forces between separate molecules that make them stick to each other? And this is where my favorite analogy comes in, glue versus Velcro. Those chemical bonds we talked about, ionic, covalent, that's the superglue. It holds the atoms together inside a molecule, and it is incredibly strong. But the forces between molecules, that's more like Velcro. Much, much weaker, but absolutely essential for figuring out if something is a solid, a liquid, or a gas. Okay, let's put it all together now. We've talked about the why, the how, the shape, and those in-between forces. Now we can finally go back and answer the questions we started with. So, why is salt a solid? It's because of that ionic bond superglue. It locks all those sodium and chloride ions into a super strong, rigid grid that takes a massive amount of heat to break apart. And why is water a liquid? Well, it's not because of its internal bonds. It's because of the Velcro between the water molecules. These weak attractions are just strong enough to keep the molecules clinging together, but they're also weak enough to let them constantly break and reform, allowing them to flow. From the phone in your hand to the air you're breathing right now, everything is defined by these fundamental rules of giving, sharing, and repelling. So the next time you look around, ask yourself, now that you know the rules, what other invisible glues can you see holding your world together?